In this video, I'm going to teach you about dimensional analysis. And the big thing with dimensional analysis is that when I teach it to you right now, I'm going to teach you how to convert within the imperial system. So it's a lot of units that we use in the US. It's units that are not included in the metric system. And I know that that's really easy to just plug into Google and get a quick answer. And I completely understand that. But what I really want you to focus on is the method and the process of using dimensional analysis to convert between units, because later in the year, we're going to get to something called stoichiometry. And stoichiometry pulls on the dimensional analysis method. And if you have that method down, Stoic's going to be super easy. And if you don't have dimensional analysis down, it's going to be difficult. So let's get into what dimensional analysis is. So again, I said that you are going to be converting with units of the imperial system. So that's units that we use here. So for instance, like tablespoons to cups, grams to pounds, kilometers to miles. That's going to be like tablespoons, cups, pounds, miles. Those are in the imperial system. Those are units that we use in the US. There's also going to be some metric units that we either can start with, end with, go through in order to convert between units. So some of the dimensional analysis problems will just be with the imperial system. Some might involve the metric system as well. It all just depends on the problem, okay? But either way, it's the same method. Some things to kind of go over before, again, we get into the problems is that you can multiply anything by 1 without changing its meaning. When we do dimensional analysis, we are going to be using conversion factors that are really just two exact numbers that are put into a ratio that is equal to 1. So for instance, if I'm converting 1 mile into feet, I'm going to have to use conversion factors, multiply, divide, all that good stuff. So I will be changing the value, and I will be changing the unit from miles to feet, but the value that I get out of that calculation is going to be the same length as what I started with. Now, a conversion factor is going to look something like this, right? So we will take two exact numbers, like 1 foot is equal to 12 inches. It's the same exact length. It's just, again, different units, different number, but it's the same length. In essence, it is the same thing. And if we can put that into a ratio or a fraction form, 1 foot over 12 inches, that's going to be equal to 1. And likewise, if we flip it, 12 inches over 1 foot is also equal to 1. So we could multiply something by either one of these conversion factors. And yes, it would change the number. Yes, it would change the unit, but it would not actually change the essence of that value. It wouldn't change the length. It would just convert it into a different unit. Now, you are going to have to differentiate between which one you use in an actual problem. So you might have to ask yourself, do I put feet on top and inches on the bottom, or inches on top and foot on the bottom? You might be thinking right now, well, it doesn't matter because they're both equal to 1, but it actually does matter. It really depends on the direction that you're going and what unit you're trying to convert to. And you're going to see that when we get into some practice problems, that actually the correctness of your answer relies on whether you choose 1 foot over 12 inches or 12 inches over 1 foot. Okay, so we are going to kind of go through the steps of solving a dimensional analysis problem, and I am going to start with just a single unit conversion. We are going to start with 1 unit and we are going to go to another single unit. So let's say that I have an example problem of I want to convert 5.54 inches into centimeters. So the first step for all dimensional analysis, and again, we are focusing on the process here, not the actual calculation. We are going to draw something like what's on your screen. I call it a picket fence. whatever you want to call it, that's fine, but you need to draw the lines. Our second step is then going to be that we are going to write the number that's given to us in the problem in the upper left-hand box. So if my question is, how many centimeters are in 5.54 inches, the only value given to me in that problem is 5.54 inches. That value goes in the upper left-hand box. For a lot of the problems, it's going to be very easy to pick out what number goes in the upper left-hand box because it will be the only number in the problem. When you start getting into story problems and more challenge problems, then it might become a little more difficult. You have to kind of think about it. So my 5.54 inches is going to go in the upper left-hand box. That's step 2. Step 3, I always encourage students to write whatever your final unit is at the end of your picket fence. So in the question, I asked you to go from 5.54 inches to centimeters. I put equals question mark centimeters, so it's my reminder to know what unit I'm trying to convert to, and so then I know when to stop doing the calculation. Okay, you don't need to do this step. I just encourage students to do it because sometimes they get confused, go too far, don't go far enough. It's just kind of a safety step. The next step is to start using your conversion factors, and you actually have a box of conversion factors at the bottom of your metric stair reference sheets. It has all of the imperial system conversions that you will be using in this part of the class, as well as some that go between the imperial system and the metric system. So one of those conversion factors that you will see in that box is that 1 inch is equal to 2.54 centimeters. Now these are exact numbers. So if I have the conversion factor 1 inch equals 2.54 centimeters, I can use that to convert from inches to centimeters. That's very obvious. Sometimes that conversion factor that you need to use is not going to be that obvious. What if I asked you to go into yards instead of centimeters? There is no conversion factor on that sheet that goes straight from inches to yards. You might have to go from inches to feet and then feet to yards. So sometimes there's going to be multiple steps, and honestly, most of the time there's going to be multiple steps that you just have to think about prior to kind of working out the problem. And sometimes I encourage students to actually write out the roadmap. So inches, arrow to feet, arrow to yards, so that they know the units that they have to go through in order to get to their final unit. And after a while, you'll just know. Like if I'm going from inches to miles, you'll get that down that you have to go through feet first. Okay. So now that I have my conversion factor, this is a really, really important step. Okay, you are going to put the part of that conversion factor that has the same unit as the starting box. You're going to put it diagonal. If you have inches up here, you want inches diagonal. And the reason for that is we want these to cancel each other out. We are trying to get a number with the unit of centimeters. We don't want inches anywhere in our final answer, so we need to cancel out the inches unit so that we can completely convert that 5.54 into centimeters. Okay, so we put the inches diagonal. That's a huge step that you got to get into your head. You got to practice that. And then you're going to put the other part of the conversion factor on top, because remember, that is going to be equal to 1. So we have the 2.54 centimeters above the 1 inch. Okay, so these 2 inches are going to cancel out, and we're going to be then left with centimeters, which is the unit that we wanted to go to, right? So if there were more, we'd have to go through more steps, but there aren't because we're already in the final unit that we want. So then the way that you would plug this into your calculator is you multiply across the top and you divide across the bottom. So if I have what's on the screen, I would plug it into my calculator as 5.54 times 2.54 equals, and then divided by 1. Okay. If there were other values in here, right, I would do this 5.54 times 2.54 times whatever numbers in this box times whatever numbers in this box equals, and then divided by 1, divided by whatever numbers in this box, divided by whatever numbers in this box equals my answer. Now that's a single unit conversion. Those are fairly simple. The derived unit conversions are going to deal with units that contain 2 units in them. Okay, like miles per hour contains miles and hour. So we're going to learn how to convert between derived units. So it's basically what you just learned about single unit conversions, but you're going to do that twice. So my question for this part is, how many inches per second am I traveling if I run 9 miles per hour? So you're going to start with the same step. You're going to draw the picket fence or whatever you want to call it. And the second step, like in the single unit conversions, you're going to put the value that's given to you in the problem in the left-hand box. And it's not just the upper left-hand box anymore. It's going to be the upper and lower left-hand boxes. So if you look at the value that's given to us, we have 9 miles per hour. And if we were to write that in a fraction form, right, 9 miles per hour means that you are traveling 9 miles per 1 hour that you were traveling, right? So this can be written in fraction form, just like what I did on the picket fence. So you need to put the value given into the picket fence as a fraction like this. So then the next step is that you are going to write your final unit at the end. Just like I did for the single unit conversions, it's a great practice to get into. So I know that I'm going to inches per second, so I wrote that at the end so that it's kind of my way of remembering this is what I need to go to instead of having to find it in the problem. Okay. Your next step then, I am going to put a box, like a red box, over the hour because we are going to completely ignore the hour unit for now. So ignore the bottom unit. We are just going to focus on converting the top unit first, acting as though this bottom unit is not there. We'll come back to it, but we're just going to ignore it. So we're going to go through the same exact steps that we did for single unit conversions, because again, we're going to worry about the miles right now and completely ignore the hour. So it's like we're doing a single unit conversion. So we are going to use conversion factors to change miles into inches. If you look on your conversion factor sheet, you will not find a conversion factor that goes miles straight to inches. We're going to have to do multiple steps in order to get it to inches. So you should see the conversion factor that 1 mile is equal to 5,280 feet, right? And then you should know, kind of common sense, that we can go from feet to inches because there's 12 inches in a foot. So that's going to be our game plan. We're going to go miles to feet, feet to inches, because inches is what we want to go to. So if we know that 1 mile is equal to 5,280 feet, right? I just say it 5280. I know it sounds weird, but that's just how I say it. Since we have miles in the upper left-hand box, we are going to put the mile portion of that conversion factor, which was 1 mile, diagonal from it so that the miles will cancel out. So we're going to put the 1 mile diagonal because we want these to cancel out. And then I'll put the other part of the conversion factor, which was the 5,280 feet, on top, right? So since my miles are canceled out and we're ignoring the hour, technically we're now in feet. Our value is in feet. So now we need to convert from feet to inches, and you should know that there are 12 inches in a foot. So I'm going to put the part of that conversion factor that has the feet diagonal. So I know in every 1 foot, there are 12 inches. So then I'm going to cancel out the feet. I'm left with inches. And inches is where I wanted to go, so I know that I can stop there. Now, it's not always going to be 1 on the bottom. I think a lot of students tend to, like when they see me do a problem like this, they automatically think, oh, the 1 always goes on the bottom. Oh my gosh. That's not always going to be the case, which you'll see in a second, but just make sure that you know that. Sometimes these can be flipped. So now that we're in inches, right, we are now going to go to the next step, which is ignoring what we just did. So we're ignoring the distance unit now, and we're just going to focus on converting the time unit. So we have hours down here, and we want to get to seconds. So we are completely ignoring all of this that's covered up in red, and we're going to convert hours into seconds using the same exact method, but we're going to do it kind of reversed. And when I say reversed, I mean that we are still going to put the same units diagonal from each other, but since I'm starting with hours down, I'm going to end up now putting hours up. So that's the reversal part. Instead of going diagonal down with the same units, you're going to go diagonal up. So I know, right, common sense, but also on your conversion table, you know that there are 60 minutes in an hour. And minutes is a lot closer to seconds than hours is, so we're going to go from hours to minutes, and then you should know that we can go from minutes to seconds. So we know that 60 minutes in 1 hour is a conversion factor we can use. Since hour is down, we're going to put the hour portion of that conversion factor up. Remember, it's diagonal so that hours can cancel out. And we are going to put the 60-minute portion on the bottom. Okay. And then since I have minutes down, I know that there are 60 seconds in 1 minute. So I'm going to put that 1 minute portion of the conversion factor diagonal. So I need to put the 1 minute up, and then I'll put the 60-second part of that conversion factor underneath. Okay. So now that we have this in seconds, right, that's what we wanted to get the time unit into, so we can stop there. Okay. Now, the next step is to check and make sure that all of our units cancel out and that we are left with our final unit in the correct places on our picket fence. So I'm just going to go through and actually slash out the canceled units. So these miles, since they're diagonal from each other, cancel out, as do the feet. And then we are left with inches, right? There's no other inches anywhere on this picket fence, which means that this is one of our final units. Our hours are also going to cancel out because they're diagonal, as are our minutes and our seconds. There are no other seconds on our picket fence, so that is going to be one of our final units. And you want to make sure, looking at that final unit, inches per second, that the first part of that, the inches, is on top. This is per, this line represents per, and then seconds is on the bottom. So we know that we did this correctly. So then when you plug this into your calculator, right, you multiply across the top and you divide across the bottom. So 9 times 5280 times 12 times 1 times 1, which you wouldn't really have to plug those ones in because it doesn't change the number, but just going through the motions here. And then I like to hit equals just to make sure. And then I do divided by 1, divided by 1, divided by 1, divided by 60, divided by 60 equals, and you should get an answer of 158.4 inches per second. Okay. If you plug that in to your calculator, I really encourage you to try plugging this into your calculator. And that's going to be it for dimensional analysis.